Hello, today I going to talking about the binary tree vertical order traversal. But this question is premium, so which means you need to buy the premium. Otherwise, you cannot open this question and solving. Here, also this question is very popular. Got asked by the big tech company. So you can see here. So recently in the Facebook, Amazon, Microsoft, and TikTok, this big company asked this question. So if you like solving coding question, I think you need to buy the premium. Now let's get started and go through this question. And given the root of the binary tree, return the vertical order traversal of its node values from top to bottom, column by column. If two nodes are in the same row and column, the order should be from left to right. I think the question is straightforward, right? You can see in the tree, and you can see here 3 and 15 in the same column. So we create a list to store these two values. And you can see 9 should become before, because 9, this node is in the left of the current node, right? In the root. So you can see 9 comes first, and 3 and 15 comes later. We just follow this way. So here we need to use the column to keep track of the smaller column and the maximum column, or you can say leftmost column and the most rightmost in the column, right? To keep track of this order. And in here you can see, I think it's pretty simple to understand, but how to achieve this coding, I think it's more complicated. So so I think we can create a zero, because we need to traverse the entire tree, right? We always start from the root. So here we can create, we need to go through this one first, and then we create the zero as colon for this root. So here we need to create the info class. The info class contains the current node and its column. So if the current node go to left children, so which means here should be -1, and go to right, just increase by 1, right? So here we just decrease by 1. Just we get a previous column, and if you get left, you just previous column -1. So we get a -2, right? If go right, here should be 0. And then here same thing, -1 is 0, and then here it should be 2, right? I think it's pretty simple. So we need to use the info to store to maintain they have two fields, right? One field is current node and its column. Where is the which column is the current node is. So here, this one is our return type. If you see the return type, if you see the return type is the nested list, right? So here is our return type, and here is Q. When we create the info object with the current node and the column, so we need to put it in here 3 is the value, and with the column. Now when we now here, this one is our first step, and the second step we need to pop up this one, because we need to pop up this one. And then when you pop up this one, the value in the queue, okay, I forgot to mention why I use the queue. In this solution, I use the BFS and the hash map. Because hash map, the key key mean is colon. Which colon and the value is a list of value. So we know here these three value in the colon 0, right? So here we can see in the colon -1, -2, they have two, and they do only one value. So we don't know how many value in a particular colon. So here we must use the list because list is it can dynamically increase the size, right? So it can be used here. Next, when we pop up need 3 from the queue, now we need to check hash map. Do you can see here his column, right? We need to check the hash map have the 0 colon 0 or not. We know here obviously he has no colon 0. So we need to create the keyword pair 0 with the 3. 3 is the value. And now when we finish this here, we need to check the left children. So we know left children of the current node is 9. 9 is predate the tree. So we know we need to create a new info object in the queue 9. And we need to, because go to left, right? Traverse to left children. So here -0 minus 1 is -1. Now we need to check the right children. So we see the right children's A is present in the tree. So we know here A with the 1. Okay. When we finish this one, we need to update here. The minimum, the current, initially the minimum is 0, maximum is 0. Now here we obviously it should be -1, and here's 1. Why here we need to, because the question say in order to be from left to right, so we need to use the, so we can see here the final the minimum should be -2, and the maximum is should be 2. So we will go through 0, 1. We will go through this -2, -1, 0, 1, 2. We need to go through the hash map with this index, or we can say it's column. So we need to check -2, because the list in the -2 column should become first, and then we need to print out the -1 column. So we need to this way can easy to follow the order, ascending order. Now, so we'll count this out. Now we need to do printing. We need to pop out this 9 from the queue, and when we pop on this queue, we need to check the hash map is contain the -1 colon or not. Obviously, it's not, right? So we create a new key winner pair with the 9. After here, on the next step, we need to check the left children of the current node. We know it's 4, right? 4 is present in the tree. So we need to create the 4. We need to create the info object. The 4 with the -2, right? Be go to the left children. Now we just follow this. We just repeat this step until we going through the entire tree. Here should be 0 with the colon. It should be 0. Now we do here. If the colon already exists in the keyword pair, we just add, because this one is least, so we just add it. If the colon already exists, we just add the value at the end of the list. We just use this way, and then when we finish the entire tree, traversing the entire tree, we just go through the hash map with this the index the column, right? -2, -1, 0, 1, 2, which found this one. because this column will store in the hash map. And then let me show you the code. So here you can see. Okay, here I first step I just create a race its result because it's our return type. So we obviously in the first step we need to create a return type, and then you can see here why I check the root equal to no, because you can see the range start from the 0, so it's possible root is no, right? So here we need to prevent this edge case, and then create this one, and queue we create the info object. Okay, here we maybe here I use the left mouse and the right mouse. It's more. You can use any variable name here. Now when we add the info object into the queue, we need to check while loop. If the queue doesn't exist any info object or any node in the queue, we know we need to break. The while loop will be break. And then we just go through this one, and to get each each list each column, right? And then we just return a rest here. Why here using the size? Because we is used to limit the size of each row. And then here we just pop up, and then we need to check the column exists in the hash map or not. If not, we just create a list. The list means it can be multiple node in the same column, right? So here we need to use the array list or linked list is up to you. And here add the value into the list. And here we need to check if the node on left not equal to no. Okay, we'll create a new info object in the queue, and we need to keep updating the leftmost value. And here the same thing go to right, and then we just printing just go through each column and again the list, and put it in a result. And then here is our the time complexity is B of n, space complexity is B of n because I use the hash map here, and why time complexity is n, B of n because I just go through the entire, just traverse each node only once, so that's why. And thank you so much for watching this video.